Hi everyone, I am Arhan İlhan and here is my Physics 212 project using cloud chamber in observing radioactive particles. There are atomic particles flying all around us, and most of these particles come from outer space as cosmic particles. These cosmic particles include positrons, electrons, protons, neutrons, pions, kaons, and most importantly, muons. Muons constitute a big portion of these cosmic particles. There are also particles emitted on Earth from radioactive materials such as radon in the atmosphere, thorium in rocks, and potassium in bananas. These particles are emitted by radioactive decay, which has three main types. Alpha decay occurs when a material emits a positively charged helium ion. A beta decay occurs when a material emits an electron, and gamma decay occurs when an excited atom emits a high energy photon. Here are the characteristics of these particles. Alpha particles are heavy particles with low penetrating power and high ionizing power. Beta particles are light particles with intermediate penetrating power and intermediate ionizing power. Gamma rays are pure energy with high penetrating power and low ionizing power. We will be mainly observing alpha particles because of their high ionizing power. There is also a phenomenon called pair production. In this process, a high-energy photon near an atomic nucleus splits into an electron-positron pair. We also want to observe this phenomenon in our experiments. Main objective of our experiment is to detect these particles using a particle detector called a cloud chamber. A cloud chamber consists of an insulated container on top of a black metal plate. The black metal plate is cooled down to -35°C with dry ice, and a felt ring which is soaked in alcohol is placed on the top of the chamber. The alcohol evaporates on the top of the chamber and starts falling down. When it hits the cold part of the chamber, it saturates, forming a supersaturated alcohol vapor layer. When particles pass through this layer, they ionize the vapor and forming tiny droplets along their path. Different particles form different trails in the vapor because of their inherent characteristics like their mass or charge. By knowing these characteristics, we can distinguish between each particle by looking at their trails, which is the main objective of this project. When constructing our setup, we have used a plexiglass container, felts, a black metal plate, and a dry ice container. During our experiments, we use isopropyl alcohol for our alcohol vapor and use dry ice to cool down our metal plate. And we use a camera and a lighting source to document our experiments. Here is our experimental setup. We have a plexiglass container on top of a black metal plate which sits on the dry ice container. We have alcohol-soaked felt and sponges on the top of the chamber which produces alcohol vapor. Now here is a few examples of the particles we managed to document. Here are some particles that we managed to identify. Muons leave long straight trails because of their high velocity. Electrons or positrons leave curly trails because of their charge and low mass. A pair production happens when a trail splits into two trails. An alpha particle leaves thick trails because of its high mass and high ionizing power. A beta particle leaves small trails because of its low lifetime. Thank you for watching my video.